Hi all, good afternoon. We are Group 17. Myself, Shubhadeep, Sapna, Charu, and Rochak. We are presenting on our data science case study of airline passenger satisfaction prediction. So next.
Hi everyone. So I'll take you through the data set that we have picked. We have the passenger and journey details here. We also have services provided by the airlines to the customer in the data set. There are two types of delays that are for arrival and departure that are captured, and we have compared this against the overall customer satisfaction rating. We've done exploratory data analysis, and we've also identified redundant metrics and dropped them from the processing. We've used Python and Orange for predictive modeling, and the results will be shown in later in the slides. This is a distribution of age across the passenger profiles, and we see that the travelers are from 7 years to 80 years old. There is a similar distribution in terms of gender. However, we do see that economy and business class are the major type of passengers. Economy plus is very minuscule in terms of count for every age group. We see that overall count of economy plus is very low. We've also seen that only 43% passengers have ranked as satisfied. However, we do see that business class travelers are more likely to be satisfied. We do not see any trend in gender. Here are some comparisons on satisfaction level as compared to other parameters. We do see that customer aged between 45 to 60 are more likely to be satisfied. Similarly, like we said, business class travelers are more likely to be satisfied. Also, the type of travel, which is if it's a business travel need, then those customers are more likely to be satisfied. There is a direct correlation with the flight distance. If there is a 1.5 thousand kilometers distance or more, these passengers are more likely to rate their experience as satisfied. Now over to Charu, she'll take you through other parameters and their comparison.
So now we will be discussing the KPIs and how the KPIs are different KPIs are affecting the passenger satisfaction levels. The KPIs highlighted in blue will show you they are strongly related to the passenger satisfaction levels in comparison to other. In this slide, we have discussed the bar chart where we can see the in-flight Wi-Fi services are strongly affecting the passenger satisfaction levels. Going to the next slide, please. Over here, the ease of online booking, online boarding experience, seating comfort, in-flight entertainment KPIs are strongly affecting the passenger satisfaction levels in comparison to gate location and foods and drinks. Next slide, please. Onboard services, legroom experience, baggage handling services, cleanliness ratings are some of the KPIs which are strongly affecting the passenger satisfaction levels in comparison to check-in services and in-flight services. Next slide, please. In here, we have described the flight distance and delay correlation, how the flight distance are correlated to delay and arrival of departure. We can see that flight distance is not correlated to the arrival delay in minutes and departure delay in minutes, whereas they both are correlated to each other, strongly correlated to each other. In the heat map we can see that. Next slide, please. We have in the slide we have shown the box plots where we have done the class wise comparison, where we can see the different KPIs where a business class are more satisfied than eco plus and eco class. Next slide. Over to Rochak.
Thank you. Coming to the modeling part of it, we have we've tried an exhaustive approach towards modeling this customer satisfaction. We are evaluating our models based on 4 parameters. On the bottom right, if you see predicted value equal to 1 is when we are correct. And when we match, we are true positive. Accordingly, we have calculated our accuracy, precision to check how precise we are, and recall to check how much of our samples could be identified correctly. So based on all these 4 parameters, F1 score being the harmonic mean of the two, we are evaluating our models. Next one. Logistic regression, is on the regression side, which we have picked, and then on the classification side of line of algorithms, we have picked random forest and its enhancement. So here we can see that there is a 9% delta, 87.5 on logistic and 96% here. So that is very significant in the favor of classification approach. Next, please. Moving on to some variations, bagging and boosting enhancements of the classification algorithm, which we have done. We see similar results all across, except for ADA boost, I believe, in the next slide. Here we have decision tree and XG boost. On this one, ADA boost, you can see slightly lower, 92%, but in the same ballpark of 96%. Light GBM again, 96%. K neighbors a little less. So classification algorithms are doing well, especially the light GBM ones are very accurate in our case. Another enhancement is 96% for extra T classifier and bagging classifier, which is also around the same mark.
So when you pass the dataset through different models in Python individually, the results which we are showing here in the table, when it is passed individually, then the gradient boosting model is performing more than any other model. If we run the next slide, please. If we run the lazy predict library in Python and we compare the 20 models, around 20 models, then the light gradient boosting classifier is performing the most in predicting the prediction accuracy than the rest of the 19. Okay. And also we have run these dataset, this training dataset to Orange, and this is the model formulation where we have passed these dataset to 8 different models, and the results are shown in next slide. Here, the AdaBoost classifier is performing more than the rest of the 7 models. So in conclusion, we can say that, next slide, please. In conclusion, these 3 models like AdaBoost classifier, the gradient boosting classifier, and the light gradient boosting classifier is performing more in the prediction accuracy part than the rest of the models.